Thank you. Hello everyone, thank you so much for being here. In today's session we are going to do an introduction to AI-driven observability and operations in cloud edge system. First, let me introduce myself. My name is Victor Palma, cloud engineer at OpenNebula Systems. I come from Madrid, Spain, and I've been working for OpenNebula for more than 2 years. So let's move on to the presentation. And first, I would like to start with some initial context in order to introduce later what we are going to see here. So first, what is observability? Observability is the ability to understand and analyze the internal behavior of a system by collecting and analyzing relevant data. Well, that is the dictionary definition. But in other words, it's just the ability to transform data into information in something that could be useful for us. So we can have a lot of system logs or of data or number, but if we don't provide a meaning to them, it's useless. So observability have multiple sorry, I just got blank. It has some advantages, like anomaly detection that allows us to identify anomalies or bugs in our system. It also provides the ability to do performance analyze, and so we can identify areas for improvement in our system. And finally, it's very useful for decision making. So we can see the impact of the change that we made in our system in a very, very easy way. As the saying goes, information is power. So observability is very, very important nowadays. But now I would like to talk about AI, because AI nowadays is everywhere. Marketing guy's fault. But it's really useful for observability. It's really useful for observability. Well, the quick answer is yes, totally. AI, it provides to observability the capacity to create more enhancing data analysis, create automated anomaly detection, provide dynamic scaling for our cloud. For example, if we have more workloads that the usual, we can automatically create new nodes or deploy new VMs in our cloud in order to provide more services to our customers. And finally, we can create predictive analytics in order to predict how our system is going to behave in the future. After finishing this part, I also would like to talk about data sovereignty and open source, because I think the most important concept about AI currently it's the data sovereignty or the information. Many organizations trust sensitive data to third-party providers. Usually these providers are based outside of Europe, and we need a way in order to bring back the data to our servers, to Europe, and be more transparent in this way. So as a solution, the open source is a very good solution for that problem, since providing more transparency for the cloud, and helps reducing the vendor locking. in our infrastructure, so we can. We are not tied to a specific vendor, and we can migrate within vendors every time we need it. So, what's next? How can we address all these challenges? The answer is the One AIOps framework, the open source solution for AI-driven observability. One AIOps framework combines OpenNebula as virtualization and cloud management tool, Prometheus and Grafana as metrics and visualization solution, and some AI and ML algorithms to predict and analyze all the behavior of infrastructure. All the three technologies together create the One AIOps framework that we are going to see here today. So let's go step by step, and first we are going to see what is OpenNebula. OpenNebula is the open source cloud platform solution in order to create your own cloud. It provides the ability to deploy virtual machines in your own private data center, in your public cloud, or even in the edge. But you not only can deploy virtual machines, but also application containers, micro VMs, or even Kubernetes clusters. As I've said before, one of the features of OpenNebula, since it's open source and it's oriented to provide a truly flexibility to the cloud, is that avoids the vendor lock-in, so you can migrate your workloads between different providers in a very, very easy way. OpenNebula has a lot of integration with third-party tools like Terraform, like Kubernetes, Ansible, or Docker. It also has built-in tools like Sandstone, that is the web user interface, and you can handle all of your infrastructure from there or from the CLI and deploy virtual machines based on VMware, on KVM, LXD, or micro VMs in Firecracker. Finally, one of the most important features of OpenNebula is the possibility to expand your cloud to the multi-cloud or to the hybrid cloud. You can create on-demand resources on the edge in Amazon, Google Cloud, Equinix, just clicking a button or automatically if you configure that. So you can migrate workloads to your on-premise data center to an edge data center or the public cloud in a very straightforward way. So you can deploy any infrastructure with a uniform management for all this infrastructure, and you can run any application in your cloud. For OpenNebula, doesn't care if the host is located in Equinix or in the edge or in your private data center. The only thing that OpenNebula cares is what VM is running the workload and how can you access to that VM. So very handy. The next section of the One AIOps is the integration of OpenNebula with Prometheus. That integration is based on the Prometheus Sportex, like the Prometheus Node Sportex that is installed in every OpenNebula server. It's also installed in the hypervisor nodes, and it combines with the OpenNebula libvirt exporter. It's a custom exporter created by OpenNebula in order to extract and collect information about the KVM machines. And we also combine this information with the AIOps metrics of OpenNebula that it creates itself. And this metric is gathered by the 1D daemon. It's the main daemon of OpenNebula. And then exported to the Prometheus server through the OpenNebula server exporter. So the next thing is the AI that we that we add to the formula. So we create a bunch of machine learning algorithms and some decision algorithms and implement it as an exporter to Prometheus. So gathering all the metrics that OpenNebula produce and the exporter produce, we implement this algorithm in order to predict and to suggest how improve the performance of your cloud. So in summary, the feature and capabilities of one AIOps are the CPU usage prediction of the VMs of your cloud. One AIOps can predict the individual VM CPU prediction per hour, the general CPU prediction for usage for your host, the accuracy of that prediction, a very important value in terms of fiability of the system. And then one AIOps can also suggest where you can place a VM. So based on that prediction, one AIOps maybe tell you to migrate a VM from one server to another in order to improve the performance. There are three main policies configuring when AIOps. The first one is the load balancing. It's just the name said, balancing the load of in all your nodes is very useful when you have a on-premise or private data center and you want to use all your hosts. The next policy is the resource contention, so very useful for public cloud environments when you want to use a few number of hosts. And the last one is reduce migration. That policy is very useful when you want to avoid migrate VMs between hosts. This scenario is very useful for edge environments where the migration of virtual machines between edge nodes sometimes it cannot be done. So here you can see the architecture of the one AIOps. It's based on the already existed OpenNebula architecture. So everything at the bottom, it's already what OpenNebula is. And the layer at the top of the picture is the new one AIOps architecture layer. So here you can see the modules that we have implemented in order to provide this prediction and then all the virtualized infrastructure orchestrator. So let's do a demo in order to show you how this works. First, we are going to go to the OpenNebula Sandstone portal in order to show you. Wait, sorry. Thank you. I'm so sorry. Get me a minute. Okay. Well, this is the main dashboard of OpenNebula user graphic interface. Here you can see the principal information about your cloud, like how many machines we have, or the images, or the virtual network, or the usage of the host. We have currently here, sorry. In this is a demo environment, so we only have two hosts with some workload, and that these are the VMs that we have running in this environment. So this is only to see that we already have some workload in this environment, and this workload is fully random, so maybe it's consumed a certain CPU depending on the time. So when we install the One AIOps framework, and we have a documentation for that, if we go to Grafana and import the One AI dashboard, we can see this. This is the results that One AIOps generates. So we can see here at the left the average CPU predicted per host. Here we can see the average CPU predicted usage per VM, and here the real usage. So as you can see, it's closely one value to the other, and the accuracy of the prediction, in that case, a 92%. Here we can see the suggestions that One AI provides to the user. The first policy is the core optimization policy, so it's going to reduce. It's going to try to reduce the number of hosts to the minimum. Here you can see that all the VMs, we have 5 VMs in this demo. The 4 VMs are in one host, since this host is fully and not more VMs entering inside this host. We have here another VM, but it tries to concentrate the VMs in a few hosts. Here you can see the migrations that One AI suggests for achieve this distribution. So it suggests to us to move the VM with ID 3 to the host with ID 1. It's very, very, very easy to follow the instructions. And then we have the other policies, the load balancing optimization, that, as you can see, we have the VMs distributed in the 2 hosts that we have in our environment. And then the final policy, that is the migration optimization. And in this case, no migrations are suggested because no optimization are found. But well, it's in case One AI produces something, it should be appear here. And well, returning to the slides. Well, this is the demo that we have just seen. And closing thought and the next step of this project. So the next steps and challenges that we are facing in One AIOps, first is implement the virtualization operations in order to apply the suggestion automatically. Currently, the operations are only suggested but not performed in the cloud system. Then we would like to improve the AIOps distribution as part of the OpenNebula software. Currently, you need to install separately. And finally, we would like to expand the functionality to provide anomaly detections, allocation based on memory prediction and network traffic, because we only provide currently CPU usage prediction, and based on the result of the tool, creates alerts and warnings. This project is totally open source, so you can go to the repository on GitHub and collaborate and suggest new features and changes. Finally, I would like to encourage you to join to the OpenNebula community. So you can visit the forum and participate in discussion with other OpenNebula users and learn and help together in the cloud community that we have created here. As closing slide, I would like also to say that this project is funded by the European Union as part of the Horizon Europe Research and Innovation Program. So this project called CONIS, I recommend you to take a look in this URL. I can spell you if you want, COGNIT, Cognit. It's a very, very interesting project. Well, that's all. Thank you very much for your attention. So, questions? Yeah.
I joined a bit late, so sorry, I couldn't hear if you mentioned it, but what kind of model you use to predict the future utilization of the resources?
Yeah, we use linear models and Bayesian models too. Bayesian, sorry, Bayesian models and linear models.
And would you be able to share the slides in the FOSDEM website as an attachment? I couldn't find them.
Yes, I can. I can add it. You can also find it in the repository. Here in this repository, all the data models and algorithms applied are explained.
Okay, thank you.
You're welcome.
Any more questions?
Yeah.
I think basically it was the same question as the last one. If you can quickly go back to, because you did actually have the model, and then in like a couple of slides before.
Here.
So here, does it explain where the Bayesian or the linear, it's not in there, because that was the bit I was wondering how the model worked. Okay, thank you. And I'm quite interested in the AI side.
Okay.
Thank you.
Perfect.
Any more questions? Thank you very much, Victor.
You're welcome.
Okay.
Yeah.
Are you optimizing for CPU utilization or not recall it? So also, is it then possible to also say, okay, optimize for availability or network throughput?
Okay, he asked about if we optimize for CPU or for other attributes like network or memory. Currently, in the current state of the project, we are only make suggestions and predict the CPU usage. But the idea is to implement a prediction based on the network, on the memory, and other custom attributes that you want to add to the tool. The idea is that you can change the prediction, the configuration. But currently it's just a prototype.
So even storage, you mean?
For storage?
For storage prediction.
Yeah, we are also considering that.
Sometimes optimality is changing based on the cloud service provider. Did you also consider this, or is this like only based on regular hardware, or like what is your optimization?
Yeah, we are considering that too. I mean the way to optimize based on the location of the VM. It's not the same have a VM in your on-premise cloud than on the public cloud or on the edge. So it's based on different policies that we are currently defining yeah, we are considering that. Any more questions?
I think we've run out of time. So
Okay,
yeah,
thank you so much.